So I'd like to welcome everybody back. This is session 2, Professional Societies Perspectives on ET Graduates. I'm Enrique Barbieri. I'm chair of Engineering Technology at the University of North Texas. This is in Denton, Texas, close to Dallas. Anybody who doesn't know. So just a housekeeping, just a reminder. So the way we're going to do it is there's going to be cards on your tables, and if you could prepare questions, then there will be people gathering them up, bringing them up front, so that if there are repeated questions, we'll try to rephrase them and make them all look like smooth, right? So we'll try to go that way. So without further ado, we have an excellent team of panelists that was assembled today. And what I'm going to do is introduce each one briefly, and then each one will have a chance to say something about themselves and their organizations and what they're doing. And then we'll open up with some questions, and then the audience will also participate. So we have Tom Perry, who is right there. He's Director of Education for ASME. Tom joined ASME in 1991. He was Director of Professional Development after serving as Deputy Executive Director for ASE. He holds a AAS and a BS in Mechanical Engineering Technology from Penn State, a Master of Education in Physics, and is a registered professional engineer in Ohio. We have Burt Dicht. He is Director of IEEE University Programs. He began his career in the aerospace industry in 1982, held the position as a lead engineer for Northrop Grumman and Rockwell Space Transportation Systems Division. He's worked on such projects as the F-5E Tiger II, the F-20A Tiger Shark, many other F-type and Y-type advanced tactical fighters, and also the Space Shuttle. He's a member of IEEE, IAA, and he's an SME Fellow. He received his BS in Mechanical Engineering from Temple University and an MA in History from California State University in Northridge. And finally, not least, we have Joe Manous, who serves as International Activities Manager for the Institute for Water Resources, U.S. Army Corps of Engineers, and works closely with the Office of the Assistant Secretary of the Army for Civil Works in the Pentagon. Joe is a civil and environmental engineer specializing in the areas of water resources and environmental security issues associated with water. Previously, he served as Academy Professor and Director of Environmental Programs at the United States Military Academy at West Point, where he taught courses in environmental engineering, water resources, environmental security, engineering economics, and leadership. Joe earned a doctorate in environmental engineering from the University of Minnesota, and he's a registered professional engineer. So with that profile, I'd like to give each one 2 or 3 minutes or so to say something about their organizations and what they're currently doing.
Okay. Tom Perry at ASME. What we do tends to line up in 3 broad categories. And they all start with I. We strive to include and inspire, and sometimes we insist. As a professional society, it's about inclusion. And that as a result of the work we do on research projects and so on in engineering education, hopefully, and pulling out best practices and so on, helps us with some of the inspire part. The insist part comes from our participating activity in ABET accreditation. The challenges that we see, and when I talk about engineering education, I don't parse it. I'm talking about BSME, I'm talking about BSMET, and I'm talking about associate degrees both in pre-engineering and in the engineering technologies. It's general. We have struggled with where is the best place to make an impact, and where is the best place to make a difference. Lots of organizations have done things at the pre-college level and so on, and we do too also. But the most important systemic thing that I think we've done in a long time has to do with the next generation science standards. And we're I think I could be wrong, but I think we were the lead-on society in collaboration with others on urging that in public policy and so on. It seems to be taking hold because it's got engineering and technology up and down. I don't care that they're called science standards, as long as the content is in there and as long as the words are in there. But on the other end of the spectrum, on the other end of on the career side, we took a look at and began to ask for the contributions of some 2,500 engineering managers and early career engineers in industry over the last few years. And the subject was the capabilities and readiness for professional practice and industry practice, professional practice and industry of, in this case, entry-level BSME grads. We've got the data and we've got the comments of some 1,400 managers who supervise entry-level engineers, and 1,100 young engineers themselves, and also the inputs of ADME departments. This is called the Vision 2030 study. That forms our framework, and what that tells us, what it told us about BSME programs, because that's what we were looking at the time, is that the program needs to be much more focused on authentic industry application and design, build, create, make it work all 4 years. That's got implications for lots of things. It's got implications for institutional resources. It's got long-term implications for ABET accreditation processes. It's got implications for who makes up the faculty. As we began looking at that, a lot of the things that came out of this Vision 2030 about what mechanical engineering attributes needed to be, where improvements needed to take place. And we just didn't ask, where do we fix them? We wanted to know, when we got the granularity of, this is important and needs improvement. This is not important. They're really good at this, but they still need improvement. So it's a little more nuanced than just yes, no, up, down, and all that kind of stuff. And it's led to the strategy which says we really do need to look over the next years and say, how do we get to that state of design, build all 4 years in some way? And who are the faculty that are going to do it? We then began to look at professor of practice, which is an increasing kind of phenomenon, I'll call it, in mechanical engineering anyway. It's increasing because mechanical engineering departments are full of students. So what's happening is increasingly the notion of a professor of practice, not unlike a clinical professor in a med school, is beginning to be employed. Now, just as a last note there, what we begin to find out when we start looking at what a professor of practice is, we take a look at, well, there's the professor of practice at this institution, there's the professor of practice at this institution. Oh, by the way, here are the folks over here who are not necessarily at the same institutions, but who teach in mechanical engineering technology. Same thing. Industry experience. Significant industry experience, PhD in significant industry experience. There's an alignment there that specifically caught our attention. We don't know what to do with that yet, but it's there. And we are searching, and it would be useful for any comments from this group. We have been a long time doing public policy and trying to influence government policy and make people aware of government policy and that sort of thing in engineering education and in other matters, in codes and standards and all of that. We have never tackled the notion of industry advocacy. How do you want companies to support your programs. ASME has never done that. We're investigating what the answer to that question would be. Because from that Vision 2030 study, industry says, we want more of this, we want more of this, we want better of this, we want better of that. Okay, but what you're asking is a highly successful federal government funded organization called the College of Engineering that lives and breathes and is very much in the national interest of research, publicly funded research. The things that are needed in the programs don't come from publicly funded research. They come from industry engagement. They come from faculty with design, synergistic industry experience, and so on and so on. So in the interest of that notion, do be thinking about what are the messages that we want, that ASME should be giving to companies to say, support, if you want these results that you said you wanted, you need to support colleges of engineering and technology in this way, this way, this way, and this way in order to get them. Because if you don't, you're not going to get them, period. It's not in the business model. Lastly, on the pathways, you'll see the brochures there. ASME's interest in pathways comes from a number of directions. One is a very general direction and an environmental kind of scan. In the news a couple of months ago, 150,000 Social Security retirees began having their checks garnished for backdated student loan payments. We're talking Social Security retirees with that still haven't paid off their student loans. You know what it's doing to the housing market, what it's doing basically to the amount of discretionary income that people have. These adults who are experiencing this are telling your students and your future students things about how to pick an institution, how to navigate towards a bachelor's degree. What is the most economical way to navigate towards a bachelor's degree, and what is a more expensive way to navigate towards that same bachelor's degree? That same bachelor's degree. We're concerned about that. When we talk about design all 4 years, that includes 2 years at a community college for pre-engineering and 2+2 transfers and so on. When we talk about diversity, in the interest of creativity and the interest of innovation, that's why we do it. There are a lot of organizations that, including ours, that have arced over the community college as a ready population. There are lots of very productive organizations that work at the pre-college level. Our interest is in learning how to work at the community college level, and we're not good at it yet. We can use some help that way. Anyway, that's where I'll stop for right now. Thank you, Tom.
Thanks, Tom. Thanks, Enrique. My name's Burt Dicht. I'm Director of University Programs for IEEE, the Institute for Electrical and Electronics Engineers. And I want to thank you for having me back. I was here last year, and I'm glad to come back and talk about these issues. Let me just give you a little bit about what IEEE is, in case you're not familiar. We have about 430,000 members. About 100,000 of them are students, and that's undergraduate and graduate students. We have members in about 160 countries. Actually, more than half of our members are outside of the United States, so we have to take that aspect into account as we develop programs and resources for the university programs. We have about 2,000 student branches, and in the course of the year, we do about 1,400 different technical conferences. So it is quite a large organization. My role is part of one of our operational units called Educational Activities, and within Educational Activities, we cover the whole pipeline of an engineering career, from pre-university and STEM and getting students interested in pursuing careers in engineering and technology, to university programs, which I'm a part of, and I'll talk a little bit more about that in just a second, and then finally continuing education, making sure that practitioners are well-equipped to continue practicing, to enhance their careers, and stay current with technology. My role as Director of University Programs has two separate pieces. One aspect is accreditation. Tom mentioned that with ASME. So we do a good portion of supporting all the activities that take part within ABET. We cover about 800 programs, and we have a pretty involved infrastructure of volunteers that support that. There are two committees, Committee on Engineering Accreditation Activities and the Committee on Engineering Technology Accreditation Activities. And that CETAA is the committee that has me involved and actually has me work with you. We've been working very closely with our electrical and computing engineering technology department heads. And I'll talk about that in just a second. The other aspect is a new area that we've just expanded to, the more programmatic side of university programs. And that's supporting faculty, and that is supporting students. Now, we don't own any students within university programs. That's done in a completely different area within IEEE. But our focus is on developing resources that improve the academic experience. And one of the things that we want to do is try to help you, try to help department heads do a better job in terms of recruiting, do a better job of giving students an idea of the different pathways. So that actually ties in very closely with what you're going to be discussing here today. And we also recently did a survey of faculty, we did a survey of department heads, deans, industry managers, and we talked about some of the things related to pathways, related to the kind of competencies that engineering managers want to see. So I hope to be able to share some of that with you as well. And I also, at the end of the presentation, I will be asking for your help. Last year, I mentioned something called tryengineering.org. And you actually pointed out some things that needed to be updated on tryengineering.org last year, and in terms of how we labeled engineering technology graduates. They just went through a complete redesign of the website. We're just about starting to update the content, and I'll be talking about getting your help in doing that as we close out the presentation. So I look forward to your questions and further discussion today, and thank you so much.
Well, good afternoon, everyone. My name's Joe Manous, as Enrique mentioned. Thank you for the opportunity to come and to speak on behalf of ASCE. ASCE has spent the last several years taking a hard look at what is its involvement role. We're even trying to find the right verb to apply to that when it comes to engineering technology programs. And why is this? What prompted us to get involved? Because we really look at it as being other people's business in a way. It has to do with another initiative which started about 20 years ago, something called Raise the Bar. ASCE became concerned that efforts to what appeared to be commoditization of certain parts of the engineering practice, the reduction in the number of credit hours that are permitted by some legislatures for universities to have in their engineering programs, and a few other lesser important things, were causing a diminishment of the requirements to meet the minimum level of competency for the engineering profession, or at least for civil engineering. I'm not speaking for any others. Why do we care about the minimum? Because we feel we have a responsibility to the public to say, as a profession, that we don't know what anybody's going to do, but here are the minimum kind of qualifications. And as all of you know, the qualifications consist of three things: formal education, some sort of a practical experience, and then the third one doesn't get as much time, but that's personal character. And when you start dealing with the imperfect, incomplete information, and you make judgments on that from a scientific point of view, you need people to trust you. So that's where the character becomes involved. Well, because of this, ASCE set about creating something called the body of knowledge, which was an attempt to identify the areas of information that needed to be known by an engineering professional with different levels, different degrees of understanding depending on where you were in your career. And the ABET accreditation that's since been adopted for civil engineering does include the body of knowledge. And I believe the BOK is on its third revision So it continues to move along and adapt. One of the key points of that will be relevant to some of the questions later is that it has a basis, but then each school tailors it for its customer base. So it's intended to be flexible. Well, as we looked at this, and not everybody was rejoiced with us about the idea of having a body of knowledge, we said, wait a minute, what does this mean for the people that work as civil engineers? And if we're increasing the minimum level of competency, does that mean what happens to the people that are in that area that the bar moves above? And we said, we don't know. And we started looking around and said, well, who might fill that gap? And we just really looking into the dark, we started looking into engineering technology. And I think that what we've learned is that may not be the right fit. That certainly there's, I won't bore you with all the things that we have learned, but that might not be the right place. But we spent a lot of time trying to understand from that introduction, how does engineering technology and engineering fit together, or are they the same thing? We just don't know exactly. What we do know is that for a minimum standard of competency, you need a certain amount of formal education, which we've tried to outline through a body of knowledge, a certain amount of professional practice, certain aspects of character, and then of course your state licensure board will determine what those really are for any one of your graduates. Having said all of that, and that's what we're really interested in, we're continuing to move forward with better understanding. One other thing that I would mention now is that we became curious about who is advocating for this group of people. Now, whether it's engineering technologists or somebody else, I don't know what name you'll put on them, or they're just engineers, which is the title most of them use now, who is advocating for them? ASCE, they really didn't fit into what we had been doing, and maybe we should. Maybe somebody else should, and I would ask for your assistance on that. So if you're not in responsible charge, that is the person signing your name on the line and supervising other engineers doing work, where do you fall? Should you have a PE, or should that be what you aspire to? And if you, right now, there's no alternative. You either get PE, you don't get anything. There's nothing else to recognize your accomplishments, nothing else to recognize your career paths. And we sort of came to the conclusion that's a shame. There really ought to be a way to celebrate the success and the personal desires of all sorts of people working in the engineering enterprise. So that's my opening comments.
Great. Well, thank you so much for those comments, all three. So let me start things off with the following question. It touches on what Tom was talking about earlier. So we all know that traditionally ET programs are compared and contrasted with other engineering programs. The primary reasons might be to clarify the similarities, the differences, for students who may be unsure about which degree to pursue, maybe to assist advisors and counselors as they guide students in their academic program selection, maybe to educate the public in general. For example, ASME, as Tom mentioned, has produced a widely disseminated Pathways to Mechanical Engineering Careers. It's a brochure that you have a copy in your tables that compares and contrasts mechanical engineering and mechanical ET. So on the other hand, it may be reasoned that ET is as a mature, accredited degree and standalone path to an engineering career, it does not need to be placed in a comparison and contrast narrative. So the question for all three would be, what are your thoughts regarding a national effort to create engineering and GN technology brochures for each society, similar to ASME's Pathways to ME Careers, versus creating an ET brochure that intentionally avoids the comparison? And what do you think are the pros and cons for either approach?
We created that Pathways brochure and actually drew a diagram of the major ways that students progress through the system into engineering careers. We did it because because we couldn't find one that said that, and that said it clearly. There are issues in the noise in it. It's a fairly high altitude look at moving from one place to another, moving from one degree program to another, and so on. But with its major audience as a target population, as a population of people who have no idea what this is about. It's not necessarily a brochure for us. Now, we should be sure we're not telling any lies about it. But we once had a project, and a number of the societies had a project some years ago that was funded by the Sloan Foundation, and it was an effort to produce really authentic testimony for what a career is like, what engineers do and what they really do, and so on in all the major engineering disciplines, and then it went off into science, the major science disciplines and healthcare and so on. It was a significant thing for Sloan over 5 years. The takeaway from that was, or the fundamental reason for doing that, and this was inspired by Frank Manous, who was with the Sloan Foundation, his concern was for at-risk students. And his definition of a student who was at risk was a student, in our case, the student who was pursuing investing money, pursuing time and energy and so on into an engineer, into studying engineering and technology, and had no idea where they were headed. And so that notion of how do what do freshmen know when they show up, and just before they show up, that was the concern of the Sloan Foundation, and what happens from there. The other aspect currently is somewhere on the order of a 50% attrition rate. Now, you go to college. Where have you been before that? You've been to high school. What do you know from that? Not a whole lot. So you go to college to expand, so you pick a major to start out with, and you're going to learn a whole bunch of things along the way. So we expect people to change majors. It's a college, it's a university, it's an expansive experience. 50% seems a little high. So the notion of being able to chart these pathways is one we think that is important in the public interest. And as long as they're called different things, mechanical engineering and mechanical engineering technology, whoops, what's the difference? If you don't call them different things, that question doesn't arise, but to call them different things. Even if you took an approach that, frankly, if I had to do it all over again and go back to 1945 or so, and got the country to invest more in the notion of Bachelor of Science and Bachelor of Engineering, as some other disciplines have done, Master of Science, Master of Engineering, these sorts of things, to make the distinguishing factor between a heavily research-oriented preparation and a heavily practice-oriented preparation, would have done that. And it would have been a Bachelor's of Science in Mechanical Engineering or a Bachelor of Engineering in Mechanical Engineering, depending on how the program structure was, to what options you wanted to take, depending on what you wanted to do. But that didn't happen. But even if it did happen, there would be the questions, what's the difference? So we have to talk about what's the difference, because there is a difference.
I've thought a lot about the question, and at this point, I don't know the answer. Whether we should try to continue doing it separately or try to combine the two. I agree 100% with Tom that the audience that we're dealing with here doesn't have a clue as to what the difference is, and that there are true differences between the two programs. What we've tried to do at IEEE, at least in terms of our membership, from a student's membership standpoint or a member standpoint, there is no difference whatever degree you come out of college with. You know, that you're a student member or you're a member, regardless of the program you graduated from. And we have not taken the time to look at the different pathways. It's been discussed, actually it's been discussed at our accreditation committees. We've talked a little bit about it from the standpoint of our Student Educational Resources Committee that's looking at different resources for students. We've actually engaged some people in our pre-university department as well as to whether we should be doing something like this. And I think we're going to have further discussions about it. One thing we do on tryengineering.org is it clearly separates the two. And the idea of tryengineering.org is to give students, parents, counselors, advisors a chance to see the differences and then maybe choose. But what we have to do there with engineering technology especially is bring it up to date as to what's truly happening today with the programs and what graduates do with engineering technology degrees. We're a little behind in that area, and I think that will be one of our first steps. And then I think we'll continue to look at whether it should stay separate or whether we can combine the two. But I think in the end, probably we're going to be going in the separate direction because, again, they're different. I would ask you to think about, actually I was talking to one of my fellow staff members who is helping put together tryengineering.org, and her son just started engineering school. And he did a lot of research when he was in high school about the different programs and decided on engineering. And a lot of that was because, and she told me this, they heard different things about what engineering technology graduates do. And I said, well, that doesn't sound like that was accurate information that you might have heard. And so I think we really need to do a little bit more in terms of showing those pathways and showing what engineering technology graduates do. And I also think it's a case of, when we talk about the audience, if you were picking students that you think would be ideal for engineering technology programs, what would you be looking for? I don't know if we've answered that question. But that will have a big factor on the direction we go. So a lot more to come on this. I know I didn't give a definitive answer. I've given probably a politician's answer, but it's because I truly don't know the best approach at this point.
Well, ASCE has also developed a flow chart. I worked on the project about 15 years ago, and it's been updated a few times. It has a series of flow charts with lots of different pathways, and we included federal, state, and municipal pathways. Each one's different, and academia, private industry, enterprise, as well as large and small. So that's has been helpful. It's been shared, and I think students probably look at it, or young engineers, maybe more so than anyone else. And the whole idea is just to give an idea of the realm of possibilities. And that has served its purpose. As you know, you don't know exactly what your career is going to unfold. You don't know how each step's going to turn out. I certainly never thought my career was going to go the pathway it did. And I'd say that's probably normal. But if you don't know what the possibilities are, you don't know where to throw your hat into the ring. And that's what we tried to do with this document. Now, as for comparing engineering and engineering technology, first off, I have to say I don't know what the engineering technology would look like. I don't have a preconceived notion. I've spoken to department heads from engineering technology programs who have advocated that the only purpose for their program is to produce engineers, and licensures on the way is part of the pathway, and that's the way they package your program. I've worked with other department heads who have indicated that's not the way their program is structured. So what would be a document that would say, I don't know what it would be. I'd be very interested in reviewing it, and I don't know who would put it out. Maybe ASCE, that would be great. I actually think it'd be terrific. But to compare the two, seems like there's a lot of animosity between the two groups now. I'm not sure trying to make a side-by-side comparison would necessarily be productive. Maybe for the time being, just each field developing its own at a national level that provides information for everybody to share might be a good way forward.
All right, thank you. I'm sure people in the audience will be writing down questions about this topic. So let me move to a slightly different question that deals with our relation with industry. So, as you know, ET curricula strives to be closest to engineering practice, driving our need to maintain well-equipped and modern labs. Universities, however, cannot possibly recreate industry's environment because of finances, space, expertise, human resources, upkeep, and many other reasons. To compensate, faculty resort to internships, co-op programs, and all the support we can get from our industrial advisory boards and other industry contacts. We make every effort to have industry members participate in capstone projects, in graduate projects, and so on as judges or committee members. So one question to all three in the panel: what should engineering professional societies like IEEE and ASME and ASCE do to facilitate, establish, nourish industry and academic ET relations for the benefit of the students' acquisition of hands-on experience so that they're more competitive upon graduation?
You go first? Go for it. This actually ties in very closely to the question we asked in that recent survey, because we asked both faculty members and we asked industry people, managers and practitioners, what needs to happen to improve the relationship between industry and academia, and what can an organization like IEEE do? The results were very positive in that both academia and industry saw organizations like IEEE, ASME, ASCE as being a facilitator in bringing the two groups together. And I think that is something because we have connections in both areas. So I think it is something that we can do. It is something that we would like to do. And some of the things that came out in the survey were things that Enrique mentioned. There were opportunities for internships. There were opportunities for the industry to sponsor some competitions or design contests, things like that. Also scholarships. So there were a whole range of things that we saw, and again, both faculty and industry people thought it would be a good idea. So we're going to be taking that information and actually relaying it up through the organization at our Educational Activities Board, just to see what role my department might play, university programs. We are working on another program called University Connect right now that will link universities and students, and we see that as possibly an opportunity. So I would say we're all for doing this, and we see a big role for IEEE, and I'm sure the other associations as well. And maybe it is also something that the organizations, associations, we can work together to do something. It doesn't have to be something that just IEEE does or something that ASME does. But we see some great opportunities here to help that linkage and ensure that all the students have opportunities to really experience that feeling of what it is to be an engineer before they start practicing as an engineer.
Two ways that I would look at this question. One is there something nationally or regionally that can be an advocate? I think you have to make connections at the regional scale. Certainly, large schools have good connections with large engineering firms and construction firms, and that's good. But you got to be able to make those contacts if you're a smaller school, and how do you do that? I don't want to keep going back to civil engineering, but we have an organization, we have regular meetings and regional meetings, and through those contacts and the affiliations to universities, associations are made. How to do that for engineering technology programs, I would suggest that maybe making contact with other professional organizations, ASME, IEEE, ASCE. There's another one called SAME, which is entirely practitioners. They would be interested in your graduates and your students for the reasons you know. They're potential employees, and they like to give back to the profession. So I think just making those contacts, again, at the regional level is very important. The other is your advisory boards. I can't overemphasize the importance of those, even if they only meet once a year. You know, I chaired one once upon a time, and I made sure that everybody we invited was a potential person to give us assistance in how our program ran. And that was basically a criteria. It didn't have to be money, it could be services in kind, but that worked. When you invited them, they came and met the students, they sat down and chat with them, had lunch, and all of a sudden you said, you know, we're having trouble with our capstone design course, and we need people to help with this, and all of a sudden assistants started showing up. And so that became a very attractive sort of linkage. But networking is fundamentally the key.
When we talk to those 1,400 managers, and you got their inputs and so on, I say talk literally, literally, but also figuratively. We knew we were talking to the managers, not only because that's how we selected and screened and all that sort of thing, but it's also evident in their responses. And I'm going to circle this back. Number one problem, 60% of managers in industry who supervise entry-level mechanical engineers say that, and this doesn't pass the front page test, even though we're being video recorded, the number one problem that they have with mechanical engineering graduates is they are weak and need strengthening in practical applications, how devices are made and work. 60%. A smaller, but number two, and still a majority, above 50%, were communication skills. Then it went to knowledge of industry codes and standards. Then it went to systemic thinking as opposed to just component stuff. And there were a number of others, but they were further down. But those were the big strong points. And in that knowledge of how things are made and work, I kept seeing engineering technology to a certain extent, and even the codes and standards part, which in my observations is more prevalent in engineering technology programs than in engineering programs, and it used to be explicit in the engineering technology general criteria of ABET, but it got watered down some recently, to my chagrin. But where I come back to is, and just one other thing. The reason that it got reflected that we were talking to managers in industry who had things to do is when we got to the questions about emerging technologies, nanobiotechnology, all kinds of emerging technologies, and entry-level engineer preparation. The young engineers on the group were saying, we need more, we need more. The 80 departments of mechanical engineering said, we need to be teaching more. They thought they needed to be teaching more, even more than the young engineers said they need more. Down at the bottom, and I mean way down at the bottom, were the engineering managers who said, we don't care about emerging technologies so much. That's how we knew we were dealing with the frontline managers. Their time horizon was next year, next month, 5 years from now, 3 years from now, these sorts of things. They needed engineers who could produce, who could do, and make it happen. And that's where their lives are, and that's where those entry-level engineers were, and that's where they were having trouble. Now, swinging it all back, in concert with the other societies, for example, we would really like to know, in order to, if you bought into trying to meet that expectation of what the companies say they need, then we need to turn around and say, because you were talking about resources, Enrique, what should ASME be saying to its 100,000 members who work in companies about how those companies should be supporting your programs in order to achieve that result? That's important to us. And we need to sort that out sort of collectively. And I'm not sure that anybody has ever sort of nationally done that, saying, we're very used to the notion of polling companies and okay, what do we need to prepare our graduates for, and so on and so on. We're not very used to advocating for where the resources are going to come from in order to achieve that. We're used to it with government. We're not used to it with industry. And for the professional societies that are made up of people in industry and leaders in industry. And I'm talking about, 100,000 ASME members versus about 6,000 or 7,000 mechanical engineering and technology faculty who are in ASME. So this is huge majority industry reach. What do we need to say on your behalf? You can help us with that. In order to achieve those ends, not just some broad blanket thing, but if you said you want this, we think that's an appropriate aspiration. We need your help in this way in order to deliver it to you, because it's not going to come from the regular ways that things are funded. One last example, and this had to do with along that line and faculty, professor of practice kinds of qualifications. Eastman Chemical, and this is kind of the holy grail, Eastman Chemical just endowed 3 professor of practice positions at the University of Tennessee at Knoxville in the mechanical engineering department. We're going to celebrate the heck out of that. We need more of that to happen. It's got to do with labs. It's got to do with other sorts of things. Obviously, they've got to give you cash, but it's important that the human resource aspect be built in there as well. Not just the, oh, here's a project for student design and that sort of thing, which is important but insufficient.
Great, thank you. So I had a few more questions prepared, but I'm getting bombarded from you guys. So here's one that seems to be really good. So all 3 panel members spoke of coordination among discipline-based societies on many topics. So do you see a role for ASEE in convening your organizations on these topics, and what will be your acceptance and reaction to ASEE assuming this role?
I was just talking to, well, I won't go to that one, but the first thing I was thinking about was we used to have a mechanical engineering technology department has listserv in ASME. We haven't used that for years. The standard for communicating with engineering technology is the ASEE Engineering Technology Division listserv. That's how we communicate. We need ASEE. We need ASEE for those things in particular that far reach. We can't communicate, I'm not sure ASEE necessarily can either. There are 1,100 community colleges out there. We don't know how to communicate with the right people in them and who they are. We would really like a collective effort in creating a network of whether it's the program coordinator, whether it's the dean, whether it's the director. They get all kinds of titles and so on at the community college. It's not as easy as a university. A significant network of leaders in community colleges that do what we do would be very important. That voice of industry is something that's shared by all of us. So that kind of collaboration, I think, would be important among all of us.
Any comments from the other 2?
Go ahead.
Oh, we would welcome ASEE to be the kind of the facilitator of it. IEEE is very willing to participate. When I got the invite to come down here, I actually always have to run it by my boss because it's not something that's typically in my job responsibilities, but I explained what I did here last year and what we're trying to do with engineering technology, and he thought it was a good idea to be here and represent IEEE. So I think there are a lot of opportunities for us to work much closer with ASEE in this area, and as Tom said, it's being able to coordinate what we all do in terms of our professional societies. So I'm going to just give it an emphatic yes, and if we want to try to organize something, count me in.
ASEE would feel the same way. We'd be very happy to participate. We think it'd be a good idea to exchange information and see where it goes.
Great. So,
See y'all in Seattle.
So here are a couple of questions that are very, very related, and they have to do with the FE and the PE exams and credentials. So essentially, so how can organizations such as yours help efforts for states to recognize ET grads to become PEs? The other question is more related to ASCE and what Joe was talking about 3 things needed to be a professional engineer: an appropriate degree, professional experience, and personal character. So if ASCE believes that the EAC engineering degree is the only appropriate degree, why the FE and the PE tests? And if these tests measure the needed outcomes, why limit who can take the tests? So these are all related to FE, PE, and how to get there.
Sure, I'll go ahead and start. Well, the EAC accreditation is intended to affirm that a university has, a program is consistent with what the ASCE considers the body of knowledge. There's really no, it's sort of like the verification then is conducted by NCEES. So no one else has to do it. The state doesn't have to get involved. I mean, there's already a check process in place. Why couldn't another program that's not EAC accredited demonstrate that they meet the requirements that ASCE thinks should be the body of knowledge? Of course, it's really the state that agrees to that, but I mean, I don't know why they couldn't. It's just not, it's a lot more cumbersome. The fact is there is an accreditation process. It's supposed to speed this review, but the issue is, to me, is not whether it's a engineering technology degree or a engineering degree. The question is, does the program produce a graduate that has a sufficient amount of the requisite body of knowledge that's necessary? So why do you need an FE and a PE? The FE is, a lot of questions actually have been asked why we want to continue that. There are people who still fail the FE, unfortunately. You would think that if you graduate from a program that meets all the requirements of some accreditation body like NCEES or ABET, that you'd have everything down pat. But we all know from teaching that just because you taught all the material doesn't mean that everybody passes the course. And that's the best explanation I can give for why there continues to be an FE. The PE is supposed to capture the information from not only your formal education, but also your practical experience. And there are some real questions about whether the PE, I won't say, this is not ABET's position, but certainly discussion about whether the PE continues to represent the bar that should be there. I mean, that's what Raise the Bar is about. You increase the amount of content in the undergraduate education, and then you actually enforce the rules that you should about experience, then it should be harder to pass the PE. Don't know if that's really the way it's working out, and I don't know if anybody's done a scientific study to demonstrate that that's what's going on. But that's the rationale for why there's PE and FE. That's it as I understand it.
Yep, sure. We look at, when talking about public safety and public confidence, it's sort of for us, it's sort of a 3-lobed Venn diagram with ABET accreditation, industry codes and standards that are in the body of regulation that a country has, and professional licensure registration. That is fundamentally that's the basis for our profession's assurance of safety. We're not talking innovation. Innovation can be dangerous. Somewhere it's got to get safe. You have to take care of yourself. But in any case, we value the FE exam. We value the PE exam. We also have concerns that the PE exam has not necessarily evolved to the extent that it should. That bar may need to be higher, to use Joe's term. that notion of that intervening practice between the two exams and the authentic testimony of capability supervised is really important. That notion of, and frankly it's weak, the standards for continuing education for maintenance of licensure are weak. It doesn't necessarily even exist in all the states yet. But in order for someone to maintain a level of currency and a level of professionalism as the world gets more complex and as technology does, over the course of a 35-year career, 40-year career, that's only going to happen with continuing education. So one of the things that we look at is we have less of a concern about the input side than we do about the outcome side. The authenticity of the examinations is important, and the quality of that supervisory experience, that quality of that continuing ed experience, those kinds of things we think are important. We sort of come down on the side of letting our processes determine who shall practice.
And I agree with Tom. I think in terms of IEEE, we also value the FE and professional licensure. And I know that it is an important part of what IEEE promotes in terms of professionalism as well. I could not tell you, though, what we are specifically doing at this point to encourage students to take the FE. They did a study a few years ago, not on the FE, but on the PE, and trying to determine how many members within IEEE are registered. And this is only for, obviously, members in the United States. And don't quote me, I'm trying to remember the actual numbers, but I believe it's about 15% of IEEE's members are professional engineers. And that's, again, US-based members, when we have 430,000 members, most of them outside. So it just gives you an idea. But we certainly would want to do more to encourage that. A lot of it also depends the path that the graduates take. Some of them are going into fields where it might not be necessary. But even so, it is something we still encourage. This is certainly something I could bring up with our IEEE USA. That's the group that manages all the members within the United States. And professional licensure comes under their responsibility. So I'll bring that up, but again, it is something we encourage, we support, and we're willing to do more to push that forward.
Great, thank you. So if I don't actually ask your question, just blame me, So I'm trying to go with the more frequent, right? So here are three that touch on the same kind of a topic, which is 2-year and versus 4-year. And so one person says part of the confusion is because engineering technology is used to describe both 2- and 4-year programs. So do you have any suggestions about that? And then the other two deal with the AAS degree does not necessarily lead into a BS degree in many places, or even the BS ET degree, because typically AAS students don't have the same math requirements background as freshman and sophomore students that come directly into a BS ET program. So comments on those?
As I was doing some work on our tri-engineering, it was clear that the 2-year and 4-year does cause a great deal of confusion. I think if we are going to be doing something where we compare and contrast, the 2-year program needs to be considered completely separate, because 2-year graduates might truly be working as technologists in industry, and they're satisfied they got the 2-year degree, that's what they want to do. In some cases, the 2-year degree is just a feeder to getting that, to getting their bachelor's degree. So we're going to try to do some differentiation as we redo engineering.org. I'm sorry, tryengineering.org, just to see if we can do a better job in explaining what a two-year graduate might do versus what the path four-year graduates take. So I think it's something we need to look at a little further, but it was causing a lot of confusion in terms of understanding the path for engineering technology graduates.
I find it confusing too. So I would suggest a word picture. You need something that parents and students can put their eyes around and see what's involved, and more importantly, what the possibilities of the outcome could be. Whether that's some sort of a diagram or a chart or whatever it is, but something that allows them to say, look at it and say, I can see where I might fit into this, or maybe I wouldn't fit into this, but I'd fit into the other one. And because it's very difficult using words just to explain what all the possibilities are, and it's really about communication. And there's so many different pathways, I believe, that a person could take. The other thing is just to mention is the outcomes, because having talked with a lot of students, as you have, they're really worried about this semester and next semester. And what you want them to think about is what's going to happen when they graduate. What are the possibilities they could be interested in? Your really bright students usually don't have any trouble. They kind of get that right off the bat. But it's the other group who are struggling and are not sure, but they're really more focused on, I got to get through this before I can worry about the future. But in reality, they need to think about both. And I think, again, a picture is a good way to possibly communicate that.
From an ASME standpoint, regarding, I'll start off with the AS and the AAS. Clearly the first line of communication is between the baccalaureate program, baccalaureate institutions and the community colleges in the state where they live. And so I don't know how that communication works. I'm not necessarily sure what we could do to help that communication because we don't live there. And so it ties into one of my struggling issues about how to communicate choices, implications to freshmen, whether they're at university, whether they're at a college, whether they're at a community college. And in particular, how to reach them. And we're not good at that. We don't have the networks, we don't have the help. I'm not sure what to do. But it seems like something that needs to, that in the interest of these issues, because when we started looking more into community college programs than we have before, which is an occurrence of this year, the proliferation of associate degree titles is boggling. And then you load in their stackable certificates on top of that to get to associate degree titles. And it's a real salad bar nationally. And I don't know how to handle that. The way we usually handle these sorts of things is through a robust ABET accreditation. However, when there are articulation agreements between, as you know, first line in the state, community colleges and their at least their public institutions, universities, you know, making the ABET accreditation argument is a difficult one because they've already got the pathway established. You know, so to some of the more, I would say, you know, I don't want to say enlightened, but I will. Some of the more enlightened institutions who are looking beyond their 3-county area and beyond their state do wise and do consider ABET accreditation, and that helps a bit. But that doesn't cover those, you know, most of those 1,100 community colleges. At the baccalaureate level, since we've called them different things, since we, at some institutions, create different departments to run them, and we don't consider this a, a, a broader bandwidth of the engineering field. It's hard to fix that because it's been sliced and diced. So we struggle with what to do with that. And the notion of separate faculties and the notion of separate degrees in that way leads to confusion. When there are institutions who are not only have particular and I'll use the case of mechanical engineering, where you've got a mechanical engineering degree program and you've got 6 areas of concentrations, or you've got a focus in this, or you've got a focus in that. It seems like there should be a better way to be able to not slice and dice this so much, because it's confusing everybody. And one of the reasons that we have difficulty is when you look at, here's 100 and, what's the number? 140,000 undergraduate ME students in North America right now. 7,000 undergraduate BSME T student, 6%. I worry about that. And when you talk about trying to get industry input and industry testimony and so on, after I've looked at an industry study that says you really want significantly engineering technology graduates, you don't know they exist. When you see the name, you're messed up by it because nobody in your whole company ever came from that. Because it's so dominated by BSME graduates that I worry that we have a solution out there that is named wrong, that is not named for the marketplace appropriately, that does things of significant value that companies say they need and they don't know where to find it. And it's hard to see it the way it is. I don't know.
All right, thank you. So in the interest of time, let me throw these 2 questions that kind of tie into this morning's session. One of them is, do your societies work with Project Lead the Way? And how does your society encourage non-traditional learners, including vets and community college? How do they reach the engineering profession?
I'm not really familiar with Project Lead the Way, so I don't know if we're involved in that. Is that a maybe someone could just give me a little bit of background on it? You can, oh.
I could speak somewhat to it. Just
Yep.
Okay.
or we can have our colleagues speak to it. Of course.
Okay.
But I look at Project Lead the Way is frankly as the most successful engineering and technology educational franchise that exists in pre-college education in the U.S. The most successful, the most far-reaching, and with faculty development, curriculum, and so on and so on and so on. Do we have a relationship with Project Lead the Way, ASME? No. Are we happy that it's happening? Yes. Do we have something that Project Lead the Way needs? I don't know. Is Project Lead the Way a potential, depending on how they're structured, a potential transmission line for career guidance information and technical information, but principally for career guidance information from the professional societies? I don't know, but maybe. All I know is that it's very successful.
Thanks, Tom. No, I think I want to learn more about it, and I will certainly bring it up with our pre-university staff members. If there's a way we can do more to work with them, we certainly will. One of the biggest things we do at IEEE, obviously, is our Tri-Engineering, which I've mentioned, but we have something that we call teacher in service programs. And it's really more of a train the trainers type of program where we train IEEE volunteers, and we have an enormous amount of lesson plans and projects that high school, junior high school, elementary school teachers can use to encourage kids about, or interest kids in engineering, technology, science, and so on. And what we do with these programs is we do them all over the world. We bring in probably around 100 volunteers at a time and teach them how to do this. They go back to their local communities and teach the teachers there, the pre-university teachers there. So I think we've reached, at this point, over the last 5 years, probably upwards of several 100,000 teachers at this point in terms of what this group has done. So, you know, that's one of the big things we're doing right now, and I look for other opportunities, you know, and I'll certainly bring it up with our pre-university people, and we can explore other options, and with hopefully maybe with Project Lead the Way as well.
Okay. I don't know if ASCE is directly involved with Lead the Way or not. I mean, it's not been on my radar screen, but I'll find out. We do have a number of activities. It's really train the trainer, materials available. SimCity, we encourage people involved with that. West Point Bridge competition often ends up at high school level, and there's ASCE members oftentimes are participating in those. And then we have all kinds of materials that we make available for middle school connects. Have you ever seen the little things you pop together and builds things? All of that is to incite and get people excited. Rulers, pencils, you know, the usual stuff. Along that line, though, there made me think of something else. So not just educating the K through 12, but what about educating professors? We have a program called Exceed, which is a 2-week training event held in New York, also in Arkansas, every summer for the purpose of training faculty on how to be the most effective communicators in the classroom. And it's all kinds of things about how, not about technical stuff, but it's about how you make a presentation. And it doesn't matter what your discipline is, because we trained English professors, history professors, as well as engineering. But it does make a difference if you're interested, and you can see me, and I can give you the information on that. And there was one other question, and I can't remember what it was now. Remember what the other question was? Besides lead?
Oh, so yeah, so it was Project Lead the Way, and how to essentially get, you know, special learners, maybe, you know, military personnel that are coming back, and people in community colleges. How do you help them?
Again, nothing really special. That goes to the local level, and you have to reach out and get people. I'm much more involved with other professional organizations in this, working with Wounded Warriors, trying to link up, because Wounded Warriors, as you know, have fairs periodically. They just had one in Maryland where where Wounded Warriors come together with businesses, and also as an opportunity for academia and look at what the needs are, as well as the opportunities, and it's really those sort of matchups. But in terms of an ongoing program at the national level, we found it too hard to do, to be honest.
Yeah, on those programs, also, I would look. You know, we don't have any particular connection or strategy in those sorts of programs with those audiences, and we would look towards a better fit and support that fit if there are ways that ASME in particular, from a disciplinary standpoint, would be called upon to do it. We would support the Association of Community Colleges and ASEE, which seem to be a much better fit because of the breadth of military training experience, and also combined with needing to have a party at the table that is hardwired into the community colleges, because that's where the biggest value is in that kind of a transition, I think.
Okay, thank you. So, Burt, did you want to maybe take a minute and talk about the tryengineering.org and request
Sure, absolutely.
help?
As I said in my introductory remarks, we're working to update tryengineering.org. And we did some cosmetic work to actually remove the word technologist and use the term engineering technology graduates work in such and such, such and such. So, but as I look through the descriptions in all these different disciplines, and tri-engineering is not about electrical engineering, it's about all of engineering. I could use some help, or our staff member who works on tri-engineering could use some help in taking a look at the descriptions that we have and trying to update them to what current engineering technology graduates actually do. So if anyone is interested in taking part in this, I have my card here. Feel free. We'd love to have you as part of this. It's all disciplines, as I said. And along with that, on tryengineering.org, we highlight different graduates. And Liz would like to get a number of engineering technology graduates to highlight and profile. So I would ask you too, do you have some graduates from your schools that maybe you're aware of where they are, what they're doing, and if they might be interested in being part of a profile on tri-engineering, we again would welcome that. It really needs to be updated and to what the current graduates are doing. So I'll give out my cards, and anyone who's interested, just let me know after when we're done the session and during the break.
Okay. All right, so with that, I think that concludes session 2. We have a break. Please help me thank the 3 panelists. I think they did a great job. And thank you.
Yeah, thank you. Thank you. It's a pleasure.